Buzz Lightyear, Star Command. Do you read me? Buzz Lightyear out. Alright, we're in section 11.3, and this is talking about surface area of pyramids and cones. So if you've paid attention to section 11.2, some of that stuff's going to carry over because that was about surface area of prisms and pyramids. A little bit different with prisms and cylinders. A little bit different with pyramids and cones, and you'll see how in just a second. As we start here, let's define a few things for us. So a blank is a polyhedron with one face. That would be a pyramid. A pyramid, with one base. Technically, it's a face, but one base. So a pyramid and that would be the base we're talking about here. And it can be any polygon. The base of it can be. The other faces, the lateral faces, these are called lateral faces. Like we talked about lateral surface area. Those are the lateral faces. Those are all triangles, and they all meet at the common vertex at the top. So again, we have the picture to the right helps us out here. You name the pyramid by the shape of the base. So the blank of a pyramid is the perpendicular segment from the length. So that first part is important. If it is a square, it's a square pyramid. This next part, though, the altitude of a pyramid is a perpendicular segment from the vertex to the plane of the base. So again, right here, this is the altitude. The length of that altitude, and I think that's coming next, but actually no, the length of that altitude would be the height. A regular pyramid, I'm surprised that's not in here, but we have the height there. A regular pyramid is a pyramid whose base is a regular polygon. A regular pyramid. If you remember what regular polygons are, that means all sides are similar. Sorry, same length. All sides are congruent. So if it's a regular polygon on the bottom, it's a regular pyramid. Moving on, the blank. And this is an important part. The slant height. This is definitely different. The slant height. We just talked about the altitude of the regular height. The slant height is what we use a cursive L to represent, and that is the length of the altitude of a lateral face. So if you look at a side, one of the lateral faces, the length from the vertex to the base of that is the slant height. It's got to be perpendicular, as noted here as well. It's got to be, that's the slant height. And you can assume that a regular pyramid, or a pyramid is regular unless stated otherwise. So we're going to have these slant heights, and we're going to have to use the slant heights when finding surface area of these shapes. So with a pyramid, first of all, here's the theorem 11.3. I would strongly suggest putting all these theorems on your theorem sheet so you have them, because they have the formulas in them too. The lateral area of a pyramid is half the product of the perimeter of the base and the slant height. So we're going to have to find the slant height. The surface area, so we talked about lateral area. The surface area is that lateral area plus whatever the area of the base is. All right? So let's just do an example. Again, trigonometry might play in here. We have, find the lateral area and the surface area of the regular hexagonal pyramid. Lateral area and surface area. So we have to find, we're given that this side is 6. So if we pull out one of those triangles, we have the base of them as 6. We also have, we have to find the area of the base after we've defined the surface area. But anyway, we have that is 6. We have to find the slant height of that side. And we are given that, we're given it's 11. Whoops, that's easy enough. So the lateral area would be equal to 1/2 the perimeter, so 6 times 6, so we'd have the perimeter is 36, because there's 6 sides. So times 36 times the slant height, which we're given as 11. Oh, that's easy. And we can find the lateral area. And plug that into your calculator. Let me do it real quick. It'll end up being 18 times 11, but 0.5 or 1/2 times 36 times 11 gets you to 198 centimeters squared, since it's area. Now the lateral, or the regular surface area, is just at 198 plus whatever the area of the base is. So remember, area of a base, area of a hexagon, a regular hexagon would be 1/2 the apothem, which we're given is 5.2, times the perimeter, which we said is 36. Plugging that into your calculator, you get, it'd be like 18 times 5.2, but it's 93.6 is what I've gotten for that part. So when you add those up, plus the 198, you get a surface area of 291.6, and that is centimeters squared when we're dealing with area. Alright, so that's how you find the surface area of a pyramid. Now these examples below, slightly different. For instance, the one we're given, let's look at number 3. What is the lateral area of a hexagonal pyramid to the right, round to the nearest square foot? We're not given the lateral area, unfortunately. Sorry, we're not given either of them. We're not given the slant height. That's what we aren't given. We got to figure out what that slant height is. We do know that the perimeter here, perimeter is a good one to find, and the apothem is a good one to find. The apothem is 18 square roots of 3. The height of the thing, the altitude, is 42. The perimeter would be 36 times 1, 2, 3, 4, 5. Is this a hexagon again? Alright, oh well. It would be 36 for this one. And the slant height. So I'm going to pull out this thing where we have inside there, because to find the slant height, we could use this line right here. That was a really bad drawing. We could connect that triangle right there we're given right here. We could do a couple different things. We could use either that. Oh, each side is 36 feet. Sorry, 36 times 6. Which would be 180 plus 36 would be 216, I think. The slant height, we could do a couple different ways. I'm going to pull out that right triangle that's in there. So this is 42. The right triangle, we have 18 square roots of 3. That's one way to do it. You can use the Pythagorean theorem and solve it that way. Either way, you get a slant height then if you use the Pythagorean theorem. 42 squared plus 18 square roots of 3 squared equals c squared. You get a slant height of 52 if you round it. Again, rounding isn't great till the very end, but it'd be 52.3. So now to find the lateral area, we do 1/2 perimeter times the slant height. So 1/2 perimeter we figured out was 216 times the slant height, which is 52.3, and that'll end up equaling 5,649.1 if you round it there. Surface area, to add to that, we have to do the area of the base. And we add that right here, that 5,649.1 plus 1/2 the apothem, which we said is 18 square roots of 2, or square roots of 3, times that perimeter again, which is 216. All right, and as I'm going, I'm leaving these things in my calculator so they're not rounded so much. It was 5,641.133031. That's still in my calculator. Now I'm just going to add and use parentheses to do 0.5 times 18 times the square root of 3 times 216. and I get a total of 9,016.2, and that's dealing with feet, and an area it's squared. All right? So that is how you use the formulas for lateral area and surface area of a pyramid. Now there's two challenging ones here if you'd like to do it. You might have to do, actually you're given the slant height, you just don't have the side lengths. So you can use what you do have to find some missing parts. You'll have to find for example, you have to find the perimeter for this one. That's a big one that you have to find. The second one, you're not given the slant height, you're just given one of the the edges here is 10. And you're given these bases are 8. So you can find that slant height using what you know about trigonometry. We're going to go on from there so we can get to the basics of cones as well yet. So if we're going on to cones, this is going to deal with theorem 11.4. So a cone is a solid that has one base and a vertex that is not in the same plane as the base. The blank will always be a circle. That would be the base. The base of a cone is always a circle. All right? So, when we're finding lateral area and surface area, it's not much different than a pyramid. So, lateral area, we're taking 1/2. It's still, so lateral area, I'm going to write a little bit different. It's still 1/2 the circumference, so the perimeter of the base, so it's the circumference, and then times the slant height again. It's just we find it a little bit differently. So it's written a couple different ways here. 1/2 2 pi r, that's the circumference, times the slant height, or pi times the radius times the slant height, because when you take 1/2 and do the 2, that cancels each other out. And then the surface area itself will be just adding the area of the base to it. So unique ways to find surface area of cones and pyramids. We're going to do an example here with a cone. So I'm going to leave that here so we have the formulas. So let's first find the lateral area, and then we'll find the actual surface area. So the lateral area of this, you find using 1/2 times 2 pi times the radius of that circle would be 5, because we're given the whole diameter. So times 5, and then multiply that by the slant height, which we're given, or are we not given? We are not given the slant height, but we are given, this is 5, the height is 12, and if you know Pythagorean triples, that would mean that this third part of this triangle would be 13. So the slant height actually is 13. All right. Or you can use the Pythagorean theorem to verify that. So times 13 here. And I type that into my calculator. I get 5 times 13 would be 65. So it's going to end up being 65 because the 1/2 and the 2 cancel out. 65 pi, and that's dealing with feet squared. And I add that 65 pi plus the area of the base. And we know area of the base would be pi r squared. So we have r squared, so it would be 5 squared times pi. So 65 pi plus 25 pi would be equal to 90 pi feet squared. Or if you were to round it, 90 times pi is what, 282.7. All right. So, if you'd like to try a couple more examples on this on your own, there are some here for you to do. Here's one where you're just given this description. And, you know, all the things that we've been learning about trigonometry and everything is playing in here because you have to find missing parts in order to find these surface areas. So, like in example 8, it says the surface area, you have the surface area and the radius. You're trying to find the slant height. So you're trying to fill in the missing parts, use what you know, and solve. Or number 7, you're trying to find the lateral surface area and the surface area when you're just given the height and the diameter. You're not given the radius, but you can figure that out. You're not given the slant height, but you can figure that out. All right, that is how you find the surface area of a cone, or as before, a pyramid. Please go to your closing questions. I'd like you to answer these two things, and try the error analysis. Okay, look for that one. If you can find the error in here, that's pretty awesome. Then you know the surface area of a pyramid formula. But that is all I have for um, section 3 on surface area of pyramids and cones, section 3. So with that, I'd like to leave you with to infinity and beyond.